Okay, cool. So day 2 of the lab, and we're going to talk about percent yield. I warned you yesterday that we were going to talk about this. So percent yield's pretty important. It's the idea that when you're going to make brownies, the amount of brownies you can make is going to be less than the mass of the batter. Okay. So if you're going to make cookies, if you weighed all the batter and then you made the cookies, hopefully, if everything was normal, the mass of the cookies would be a little bit less than the batter. Some get stuck on the spoon, some get stuck on the bowl, and so on. In chemistry, what percent yield means is how much of what you expect, how much of what you calculate you would make, do you actually make. So in real life, you use more reactants than you calculate, and you produce less products than you calculate. And percent yield works like this. It's simply the real mass, the mass you actually gained, or that you actually produced, over the ideal mass you got from stoichiometry. Okay? Does this idea make sense?
Yes.
So in a little bit, you're going to go back to the fume hood, and you're going to weigh your filter paper that has the copper in it. Okay? Now, if everything was perfect, like the perfectest world in the entire world, the amount of copper you calculate you made would be actually the amount of copper that you actually made. But that's not going to happen, because when you made copper, some of the copper when you filtered it, some of it got stuck in the beaker. Some of it might have gone past the folds in the filter. You're not going to get 100%. Okay, make sense? Okay, and that's what you're going to calculate in a little bit. So do a quick percent yield calculation. They're very, very simple. They're always the same thing. It's always real over ideal. And for instance, if you calculated that you're going to make 21 grams of something, but you actually made 19 grams of something, the percent yield is just 19 over 21. Make sense? Okay. Alexa, what is 19 divided by 21?
19 divided by 21 is 0.904.
Okay, so about 91%. Now if you can get this kind of percent yield in actual industry, you're going to make billions. Because in reality, the percent yield is far, far lower. But anyway, so does that make sense what we're talking about? Give me a thumbs up if this concept makes sense to you. Uh-oh. Yeah? Are we doing chemistry today?
Yeah.
Okay. So, if that's the case, an actual percent yield calculation would look like this. If 35 grams of zinc reacted with excess copper sulfate and only 32.5 grams of copper are recovered, what is the percent yield of this calculation? Now in the lab today, we're not using excess anything. We use 6 grams of copper sulfate, we use a very specific amount of zinc, but in this exercise, we're going to say, all right, let's pretend we have plenty of copper sulfate, and we're going to react 35 grams of zinc, and we only produce 32.5 grams of copper. First of all, where does the 32.5 grams of copper go? Where's that going to go in our calculation? The top, exactly. So the 32.5 grams of copper is what we actually made. But to get the ideal, the denominator, we're going to need to do a little math. So we're going to start with 35 grams of zinc. We're going to convert our grams of zinc to moles of zinc. Then we're going to convert our moles of zinc to moles of copper. Then finally, we're going to convert our moles of copper to grams of copper. And that's going to give us a number. And whatever that number is how much we would make if everything was perfect. Does this idea make sense? No. Okay. Give me a thumbs up if this makes sense. Okay. So the denominator is always going to be the calculated value from the stoichiometry. The numerator is always going to be what actually happened. And sometimes you could say, all right, if I have a percent yield of 60%, and I calculate I should make 100 grams, I can expect to make 60 grams. You can calculate for the numerator if you have a percent. Does that make sense? Okay. If I said, your percent yield for your party is going to be 50%, and you invited 12 people, how many people would you expect to show up? 6. See how that works? All right, so let's talk about the lab now. So, hey Sean, can you turn the camera in this direction a little bit? So it looks like, I think, did anybody in this class not filter? I think everybody got the filtering done? Yeah, you guys are pretty fast, which is great. So you're going to see over here, you got your copperish stuff in your filter. That's great. What you're going to do is, in a little bit when I release you, you're going to pick up very carefully your filter paper and you're going to weigh the stuff. Then you're going to subtract the mass of your dry filter paper, and that's going to be the mass of the copper that you made. Make sense? And you're going to compare that to your calculation on the front of your lab that said, how much copper would you expect to make? So if you expected to make 4 grams, and you made 3 grams, your percent yield is just 3 over 4. Make sense? Okay. Now there's something I want to mention. You guys did mostly really great. I look at the copper and it looks mostly brown. But if you got a bunch of not brown, if you got a bunch of gray, then what do you think that gray is? Excess zinc. And who is this? Oh,
Yeah, someone just pure like gray.
Okay, so this is a 5th period group, and they have this giant cone of gray powder in here. You're like, yeah, you missed it by probably 7 or 8 grams. They might have even taken the lid off the zinc container. And it's just a mess. But yeah, that's just terrible. So if you do have some grayness in there, then realize that you added a little extra zinc. I didn't really see that in this class. This class seemed to do pretty good. Okay, does that make sense? Last, I did save this. This is also 5th period. What's wrong with this?
That's a lot of blue.
Yeah, there's a lot of copper in here. That means up here there's going to be a lot less copper than there should be. So would you expect that to produce a high percent yield or a low percent yield?
Very low.
Very low. So yeah, I left this for demonstration, like, wow, that's really blue. But anyway, there you go. Okay, questions? You ready to do the finish up the lab?
Yeah.
Cool. Sean, hit the button. And you guys can get your goggles and finish up the lab.